Swayam Prabha. Digital India. Educated India.
So the point is that we have a representation of the program, and you have seen through the week how one can construct such a representation. You may think of it as, passing the program through through your parser, through doing the analysis, through doing poly, clang, etc., and then eventually getting a program representation in MLIR or something like that. Okay, and in that representation, there is a mathematical way to describe polyhedral sets, right? And we are going to take that as the iteration space is defined as a polyhedral set in ISL, and that is the internal representation of this part of the program. Okay, within that you are going to access variables, and you are going to access variables with some affine function. Okay, just like we saw this many-to-one read function from the iteration space to the data space, that is the function that we are going to talk about. And that is basically represented as a mathematical function. And because it's a linear function, it is represented internally as a matrix by ISL. Okay, so you're seeing my paper? So
Yes.
I am going to show slightly differently convention. This is I, this is J. Okay, and I'm going to write this equation yi equals sigma over j equals 0 to I of xj. Okay. Now, if you notice, y is a one-dimensional variable because it's indexed by only one index. One expression inside the array means it's a one-dimensional variable. So y I am going to draw like this. Okay, it's a one-dimensional variable defined from from 0 to n minus 1 or 1 to n or whatever, right? The moment you look at this, the body of this reduction, this is a sigma. Sigma means associative commutative operator applied to sets of points. Okay, so inside the body, there is a new index j that is introduced, right? In addition to I, there is a j index, and there is a lower bound and an upper bound on j. So j goes from 0 to I. So that is basically this line and this line. And you have this triangle, which is the domain of the body expression. Okay, so inside the reduction, there is an expression. And that expression, I mean, you can think of this as a mathematical equation, or you can look at the program and you will figure out from the loop bounds that the body is evaluated in this triangular region. Inside the body, I'm reading j with a function that is ij maps to j. I'm reading the variable x, right? This is a mapping from z squared to z, a two-dimensional to one-dimensional mapping. And it is given by 0, 1. The 1 by 2 matrix, because it's a mapping from z squared to z, that means it must have only one row and two columns. Okay, because it is of the form the z prime equals a times z plus a, where a is a matrix and a is some constant vector. In our case, it's a linear map, not an affine map. Okay, you're all with me so far? So this is a function. I simply want to ask you, can you give me a two-dimensional vector rho such that a rho equals 0? A non-trivial, because if rho is 0, then of course any linear function multiplied by rho is by 0, 0, 0 is of course 0. So think back of your math and think back of your linear transformation and tell me
C comma 0.
Pardon?
It's C, any arbitrary constant comma 0.
Okay, so I'm going to choose the basis vector, which is 1, 0. So rho equals 1, 0 is a basis vector for the kernel of A. You just figure it out. I mean, you figure it out by as a human. A tool can figure it out internally, right? So the compiler can figure out that inside this triangle, if I go along 1 0 to the right, the value that is being read is identical. Of course, I mean, I can think of it as basically here is an array variable x, and at every point I'm reading xj. So everything on the same row, of course, reads the same value, right? Every point inside this triangle on the same row reads exactly the same value of x. So this is the geometry that the compiler figures out. Okay, there is another very important affine or linear function that is relevant for reductions, and that is the set of values that produce the same answer. So notice that I am writing or I'm computing y of I from points in this triangle, right? And I'm doing a sigma over j. In other words, there is a mapping ij goes to I, which is the linear function 1, 0, whose null space is 0, 1. That means along the column, along the 0, 1 direction, along the j axis, all the points that are present inside this triangle, they all contribute to the same answer. Okay? Now, all of this is pre-processing. This is known. The moment you have a program that has this kind of a form, the compiler goes in, figures out, oh, what is the domain? Where is the body defined? Oh, it's in this triangle. What is the value that is being read over here? Well, it is xj, so its null space is like this, and therefore I figure out, okay, here is the reuse space. The reuse space is the linear space spanned by the vector 1, 0. What is the accumulation space? Okay, in this case, it's the column, so it is the linear space spanned by the basis vector 0, 1. With all this information, can I change this from quadratic to linear? Here is how the algorithm works. Okay, you take this triangle, you shift it by this. So you are choosing row equals 1, 0 as the reuse vector to exploit. Okay. You take this triangle and you compute its image by the mapping ij goes to ij plus row. Translation by row. Okay, that means you compute this. Okay, I'm going to change the color. I'm going to draw this shifted one in a new color. Okay, everything that is in the intersection is thrown away. What am I left with? I'm left with the facets of the original or the new one. Okay, notice that there was also a facet of the original one that, because of the translation, was already in the intersection. Okay, I am going to throw away everything that is in the intersection, that was in the intersection, of course. I am going to throw away this facet because if I apply the projection, I get something that is outside the desired answer. My desired answer is from 0 to n. This has been shifted outside. So this facet does not contribute to any answer. Okay. And by the way, when I said compute these facets, this is what you can actually, if you want to do an exercise in ISL, you can figure this out. You do the manipulation, take the domain, shift it by this, take the intersection, take the two differences, and then for this compute its image by this mapping, and you will find that the answer is outside, and so this is thrown away. So the only residual facet that is left is this one. Okay. So this whole computation is going to be replaced by, remember, I have chosen to exploit the reuse in this direction. That means I am going to compute this answer using a previous answer. Which previous answer? Basically, the one that is from the opposite direction of the reuse. So I have the negation of the reuse vector, -1, 0. Okay. I take the image of this two-dimensional vector by the projection function. So I get just -1 because I have a one-dimensional dependence. My answer is one-dimensional. So y of I equals y of I minus 1 plus the result of this whole sigma expression restricted to just this domain, which means plus sigma j equals I minus 1. So j greater than I minus 1 to I, right? This expression. So I'm computing this answer using this answer, right? So not I minus 1. J greater than or equal to I to I. Only the last value is left. Okay. Remember, I have this facet, which is the difference between the original domain and the shifted domain. So there is only one line that is left. And so this sigma goes from j equals I to I of xj. But there is only one point in this dimension. So this can be simply, this can be rewritten as, okay. We have to be careful about this. This, when I apply the I minus 1, gets me outside the domain. So this is a special boundary condition. And so it will become, if I equals 0, you have y of x of 0 or x of I. Okay. So this is the reasoning and this is the manipulation that a compiler will go through in order to convert a program like this or an equation that represents a program like this, okay, into a new equation like this in which the complexity is linear. Okay. Will you be able to do an exercise for me? So what if I tell you y of I equals sigma x of I minus j, j equals 0 to I. So I'm just changing this function. Can you go through the thinking and the reasoning? Y is an answer that is defined over a one-dimensional space. J equals 0 to I, so my domain is still a triangle. Answer is here. My accumulation space is ij goes to I. Its null space is 0, 1, right? Now the only difference is this other function. So tell me what change happens. You are still reading a one-dimensional variable x, okay? But in this point ij in the triangle, you're reading memory location I minus j. 3 steps, right? What is the read function? I put some questions in the chat box. What is the read function? In ij, I'm reading I minus j minus I. Oh, no wonder you guys are confused. This should be j minus I, of course. Is that why you were quiet?
Is it j minus or I minus j? Because j would be less than.
Right, I minus j. Yes, sorry. See, keep me honest. Please keep me honest. Otherwise, I'll tell you all lies.
So on this, the x would be, I mean, on the diagonal, or is it? Do we consider it on?
You are exactly getting there, right? So if I think of this, how, basically I minus j equals some matrix A times ij. It's a 1/2 matrix, right? This
Yes.
expression is some linear combination of I and j. What linear combination of I and j is it? Given by the matrix 1, comma minus 1,
Oh my one.
right?
Yeah.
1, comma minus 1 times ij is
And
I
the
minus j.
null would be 1, 1. But I forgot the further step.
Yes. So 1, 1 is rho, which means if I
Yes.
take this triangle and inside this triangle I move in this direction, I am
Yes.
reading the same value of x,
Okay.
right?
Okay.
This point reads x0. All the points on this diagonal where I equals j reads x0. All the points over here where I equals j plus 1 read x1, etc., etc. And this last point reads xn or xn minus 1. But the pattern where the same point is being read is along this 1, 1 direction.
Yes.
Agreed?
Yes.
Okay. So if that's the case, then I should take my green triangle and I'm going to shift it in the 1, 1 direction. And what do I get? I get this black triangle, which is like this. Okay.
Shift it towards. Okay.
Shifted northeast.
Yeah. Yeah.
I'm going to delete everything that is in the intersection. And I'm going to be left with this is already in the intersection, this diagonal edge. This edge of the triangle shifted points gives me something that is outside, disappears.
Yes.
And I am left with this residual computation. And again, it is one-dimensional,
Yes.
right?
Yes. So how
Okay.
do you write this? The bottom one.
The bottom one is basically the same body, okay, x of I minus j, but restricted to the set ij such that 0 less than or equal to I less than n and j equals 0. It's a two-dimensional set. It was basically, and ISL can compute this set for you. If you take the triangle and you translate it by 1, 1 and take
Okay.
the difference, it will give you this. And this line is just, it's a polyhedral set. It's a set of points which satisfy an equality, j equals 0. That's why I said it is it's a facet of the triangle. Instead of something two-dimensional, it's just a line segment. Right? Because it's satisfied, it is embedded in the ij space, but it has this equality. So this is the polyhedral set on which the reduction body is defined. Okay? So now I take 1, 1. I take the negation of that and take its projection by the accumulation function, and that gives me minus 1. Right? The accumulation function is ij goes to j. So 0, 1. All points in a column go to the same answer. So 0, 1 is the projection function of the reduction. That multiplied by the row that I've chosen, which is 1, 1, is equal to, or the negation of the row that I've chosen is equal to minus 1. So I'm going to say y of I equals y of I minus 1 plus something. What is the something? The reduction body at, this reduction body at I, right? Which is equal to sigma. And, when I say j equals 0, sigma, if the bounds on the summation is simply j equals 0 to 0 of x I minus j. Okay? If j equals 0 to 0, this is the same as xi. Okay? So this is what it computes. And by the way, all I did was showed you exactly this equation. It is also a prefix sum, but written as a different equation. It was written like an equation like this. But if you look at it, all of these points read this value, right? So this is the summation of this plus this plus, the summation of all of these values in this triangle is the summation of these values being read. So at I am computing just the prefix of x and adding them up.
So
It's just,
the one step I didn't understand where we multiply 0, 1, which is the projection, by minus of 1, 1, which is the row.
oh, but that, because that is the rule for the simplification. I am, if I am, so the argument, the rule is as follows, right? So if I observe that many of these values are identical to many of these values by shifting like this,
Okay.
right? All of these values contribute to a majority of these answers. So this answer can be computed from the previous answer
Yes.
plus whatever is left.
Okay.
Okay. So whenever I choose to shift to the right, I will depend on the value to the left. This is in a two-dimensional space. This is in a one-dimensional space because this is just one answer. And so I have to apply the projection function to the negation of row. Okay.
Okay. Okay.
So that's, it's just,
So we're calculating the negative projection
you are calculating the negation of the
of
shift
project.
vector and projecting that.
Okay. Okay.
All, that is what the compiler
Yeah.
will do when it constructs this new equation.
Okay.
Okay. So you can write this as an MLIR pass if you want to do that. Okay.
Yes.
All right. I'm I think you guys are all tired, so I'm going to go. I'm willing to go as slow as it takes. And I'm going to give you a different example, but also very interesting. And this is
Excuse me,
actually a
Professor.
practical. Pardon?
Like from the original equation to the one we've reached, like what reduction have we actually brought in? Like we still have xfi and we still have like, oh, we lost j. Never mind.
We lost the j index. See,
Yep.
j goes from
Exponent
0 to 0. So j can be, you can substitute it
Yeah.
out. Instead of a quadratic, instead of computing the body on an entire triangle, I'm only computing the body on a line. Okay.
Is this somewhat like a PCA? Is this a bit like principal component analysis?
It's nothing like principal component analysis. Principal component analysis, looks at data values, and in that data value, it determines basically
An
eigenvalue.
eigenvalue and then
This is nothing like that.
okay.
This is a program analysis technique that is used to discover from a simple specification of a program. It is used to discover efficient algorithms that implement that specification.
Mm.
Okay. I'm going to give you a practical example that is slightly different. Okay. It comes from image processing. It's called a line of sight. Okay. So you have some data. Okay. And at every point ij, there is some elevation. It's some hilly terrain, right? And so you have the elevation. I'm going to call that a variable z, and you see what it is. Okay. And you want to determine whether for every point inside this image, you want to determine whether it's in the shadow or whether it's in sunlight. Okay. Whether from that point you can see the sun or not. Okay. What information in addition to the elevation would you need? to solve this problem.
So can you please repeat?
So I'm asking you to solve this problem, and I'm saying that I haven't given you all the information. What information do you need in addition to that?
Coordinates of sun.
Coordinates for the sun. The sun is at an infinite distance, but you are absolutely right. I need some information about where the sun is. Okay,
Yes.
sun is at an infinite distance. So what really do I need about the sun? Maybe not in Cartesian coordinates. Can I think about some sort of a polar coordinates for the sun?
Angle we need.
Which angles do you need? Do you need one angle or multiple angles?
One angle should be sufficient.
You are on the equator? You need two angles. One is called the azimuth, which is basically, is the sun rising in the west and going to the east like it happens on the equator? Or whether you are at some altitude, in which case the sun can rise north of the equator depending on the season. Remember, it doesn't rise exactly due west. Okay, so at any instant, what you need is in the XY plane, you need an angle of the sun. That's called the azimuth. Okay, and then you need the elevation of the angle, and that's the theta. So you need phi and theta, the polar coordinates of the sun. Okay. Now I told you all this. I made you feel guilty that you didn't know all these answers, and I'm going to simplify my problem. So if I know that the azimuth is like this, then I go along this direction, phi, and only the points here are potentially going to cast a shadow on me. None of these points over here can cast a shadow on any given point ij, right? So I actually have to consider for any point ij only one line of points. And I'm going to simplify that problem for our sake by saying phi is equal to 0. So the sun is in the west and goes in the east. So only these points in a row are the potential points that that can cast a shadow on me. Okay? With me so far? In other words, if I have I and j as my two space data axes, I can formulate independent problems for each row. So I'm going to ignore the j axis, in fact. Okay? So I'm going to say that point I is in shadow if what? And I know theta now. I know theta, and I'm assuming phi is equal to 0. So given this information, and remember I have now z of I, right? That is the altitude of this point. Can you describe an algorithm or some condition that must be satisfied in such a way what are the conditions that must be satisfied that I is in shadow? So let me show you the cross-section view of this hilly terrain. So I'm going to show the I and Z of I axis, and I have some elevation like this, okay? And let's say the angle of the sun is this theta, let's say it's 30 degrees, okay? Then, is this point in the shadow? Or can you see the sun from here?
We can see the sun.
30-degree line, and if I encounter some other point that is higher than that intersects that line, You can see the sun, right? All along this, you can see the sun. Okay. What about this point here?
It would depend on the angle, but I think with the image, I think we won't be able to see.
This, that's why I drew it in red. I drew this in
Yeah.
red. Drew this in red, right? So probably if I see my 30-degree line from here, all these points are in the shadow. Then some other points are now again in the sun, and I see some other band of points over here, right? And oh yeah, I'll get to them, some points like that, right? So some things are in the shadow. Maybe this is not in the shadow. Everything else here, these points are in the shadow. Maybe these are in the shadow, and depending on the angle, these are in the shadow. This is not in the shadow, but then this is in the shadow, not because of this point, but something else further west, right? You can imagine that, right? So if I ask you to write a program, if I give this to you as a programming assignment, what would you write?
We'll see towards east, and the points which are like
Towards
on,
west, right? Oh, to the left. Yeah. Okay. You will
yeah, to
see.
the left, towards left.
Let's not get worried about here.
Yeah.
The east was on the left.
Okay. Okay. Yeah, towards to the left. I think we would be seeing if the sun is on the left, and the points which are before us, if they make more than 30-degree angle.
So you are going to do something over j equals 0 to I minus 1 or something like that.
Yeah.
You're looking at all the points from j equals
0 to
0
j.
all the way up to I minus 1.
Yes. Yes.
For
Yes.
the ith answer, you're going to look at that, right?
Yes.
Okay.
Yes.
And then
If
this is making sense.
yes, there existed j such that the I mean the angle which is more than 30-degree.
Now I look at the elevation. Divided by
Divided by the horizontal
10
distance.
theta or something,
Horizontal
right?
distance, yeah. Horizontal distance, which would be 10 theta.
The horizontal distance. So which the horizontal distance is some scaling factor, let's call that h, is the scaling factor of my map times I minus j, right?
Yeah.
Okay, so this is some linear inequality, or this is some predicate on I and j. Okay, everyone with me so far? Can we make this into, yeah?
Nothing.
Can we think of somehow making this into a reduction? Because then we can try and use these, So if you think about this, there exists j from 0 to I minus 1. That means to compute this answer, I'm going to do a test of all of these points to the left. And for this, I'm going to do a test of all of it to the left, right? So if I just implement this program naively, it's going to be quadratic time. You agree?
Yes.
Can you do it in linear time? I mean, why would I introduce this problem here today if the answer is not yes?
So
Go ahead.
So there are more than one transformations here, like in
There
the
are many.
previous.
Right now, we are not doing anything polyhedral. We are just doing math, okay?
Yeah.
Because we are designing the algorithm, and not all of this can be 100% automated. So don't think that the compiler is going to do all of this. Some human input is needed. It's only when you now formulate this thing like a max over a range of values can you use what the techniques that I described.
Maybe you can store the highest value of Zi or metal now, and then
Highest. So you are thinking of max or min or something like that, huh?
yeah.
Okay, so let us look at what this means that there exists. Okay. The first thing I want to do is I want to find the expressions that involve I, not the index over the summation, that are invariant with respect to this the J index. I want to somehow pull them all out. Okay. The terms that involve I want to make them common. Okay, so here's how I do this. So I'm going to divide everything by h tan theta, and I have zj divided by, sorry, okay. Then I'm going to take the I term out, okay, and so this is zj minus hi tan theta divided by h tan theta, okay.
So we can't see the last line. It's not in the range of camera.
Okay. So all I'm doing is just basic algebra, right? So I'm taking all the j terms. So hj, sorry, plus hj plus hj divided by zj plus divided by h tan theta plus j. Okay, and I'm just writing it as one formula. So it is zj plus jh tan theta divided by h tan theta greater than zi divided by h tan theta plus I. Same thing, okay? Whichever way you want to do this algebra, okay? I want to think of this as some function g of I, and notice that it's the same function g, right? So this is g of j greater than g of I, and g can be evaluated in constant time, okay? So Si is in shadow if there exists j from 0 to I, if g of j greater than g of I, right? There exists this, and this inequality must be satisfied at all points j. I want to factor out the I part, and that is exactly where you are heading, right? There exists something. So I have a range of points, and at each point there is some function g, and here is a g of I, okay? If there exists one point over here whose g is greater than this, it's the same as saying that the max of gj, j equals 0 to I minus 1, that max is greater than gi, right? I'm just, it's something like a distributive property. I'm evaluating over only the G's, and this term is independent of I, and I'm pulling it outside. Okay? So existential quantifiers like this over mathematical properties can often be replaced by max. Another source of beautiful reductions. So now this is a max, this is a reduction. It's the prefix max. Only ending at I minus 1, that's all. We already solved that problem. It is this first example that we did, except that instead of sigma, we had max. Okay? So we are at 8:43, so I think it's time for a 5-minute break for you. It's 8:43 here, so it's 8:15 or 8:13 for you.
Okay with me, sir.
Pardon?
Okay with me, I said, but I think
Oh.
anyone else should say yes.
They're already on break.
I know.
No, so the what I want to do is sort of I want to sort of leave this with some possibly open problems. Some of them are not fully solved today. So if anyone is interested in investigating this further, there are issues. There are nice problems to solve.